Hello everybody, welcome back to Tech Talk Education. In this movie we're going to keep going down the road looking at Mutillidae version 2 inside Kali Linux in a Docker image. We got really complicated here, and I have recorded a video where you can go and find out how to install your own version of Mutillidae II inside Kali Linux so you can use it for playing around and investigating. And the reason we're liking Mutillidae is because it's teaching us how to understand web apps and how to find their vulnerabilities and things like that. So it's actually really, really useful, and it's causing us to use a bunch of different tools inside Kali. In this movie, what we're going to do is talk about HTTP, and we are going to use Kali and Mutillidae, and we're going to use Burp Suite to find some things out about this lab. So let's get started. It should be a lot of fun. Should be pretty quick. So the hypertext transfer protocol has had a long and very storied history, and we need to understand it. We need to understand where it came from, but where it's headed as well, because people just continue working on this and evolving it and adding interesting things to it. So it's a pretty interesting subject. The main idea was, hey, we needed a way to get pages from one page to a place to another over the internet. And so the HTTP protocol came about. But then people have continued to whittle on it and, add things to it and make it better and improve it, things like that. And so we probably want to understand that. So I whipped up a little PowerPoint deck here for you. It's not very long. I just wanted to go briefly over a couple of these things. So the first thing we have is a little table here. This is the HTTP history. I'm not going to belabor you with all of the details here. You can certainly read these lines on the table here. But we started out with HTTP 0, and they worked away, developed, and it became 0.9, and they're like, okay, we can now ship this. This is something that we can use across the entire internet. But it had very limited capabilities, was able to do a basic GET, and you recall that a GET is you are a user and you're going to a server or somewhere and you're saying, hey, I want to get some information from you, and that's an HTTP GET request. So it was really stripped down back in the day in 1991. But listen, this has been around quite a while now, hasn't it? So HTTP 1.0 came out 5 years later, and what they did was they extended it. So they added some things like versioning, getting some metadata out of it, some improved caching. 1.1 came along just 1 year later, but it took 2 years to roll out. It had a lot of enhancements in it, and it added some things like options and put and delete to the methods that could be used inside HTTP. It would allow it to do virtual hosting, and we improved the caching on it and some authentication mechanisms, so it was getting more and more serious. HTTP 2 rolled around 15 years later, quite a while later. And there's some interesting things that are happening with HTTP 2. For example, maybe you've never heard the term multiplexing, but if you take your hands and intertwine your fingers, you are multiplexing your fingers. That's the idea. We're taking a bunch of messages and we're just pushing them all together and we're sending them over the wire. And so HTTP 2 supported multiplexing, and it allowed servers to be able to push things like notifications. It allowed for header compression to make it much faster, prioritization to improve the speed. Then we now have HTTP 3, and this was started in 2020, and this is being recorded in 2024. So it's had 4 years to roll out and do some things. And the main outcome of HTTP 3 is a thing called Quick. So I have a separate slide for that because I want you to be able to see what that is all about. So Quick is really, really interesting. It stands for Quick UDP Internet Connections. It was developed by Google, but it was subsequently picked up by the Internet Engineering Task Force, the IETF, and they took it and began to build on it and make it workable throughout the entire web. Quick is an amazing thing. What does it do? Well, first of all, you should understand the difference between TCP and UDP. So TCP is when I make a phone call to my wife She calls me. It's a secure connection. We're talking to each other. We probably have had at some point to key in, a username and a password, some sort of authentication, or it happens some other way. But the idea is that it is a secure, encrypted connection. Nobody's going to mess around with the connection. Well, UDP was never that way. UDP was just like, we're going to fling a bunch of blocks of data out the door. They've got numbers on them so that we can reassemble them. This is block 1 of 5, block 2 of 5, etc. And when it gets to the other side, it's reassembled. But there really wasn't necessarily any security tied to that until Quick came along. Now, what we've done here, the main purpose and the main focus behind Quick is that we have mobile phones. So everybody now is connected to the web using their smartphone. It's more often that people are using their smartphone to connect than people that are on a computer or a Mac or something like that. And so we needed to think about connection times. You're in a car with your cell phone and you're traveling from one place to the other, and we're going from tower to tower to tower. What is that all about? Well, that's what Quick is designed to do. So it's going to use UDP, so it doesn't have to go through the long, big thing of getting a connection nailed up, a secure connection nailed up. It's going to reduce connection establishment time by doing so, but then it also does what's called multiplexing. And what does that mean without head-of-line blocking? Well, have you ever been at a single salad bar and there's one person right in the front, there's like 5 or 7 people behind that person, and that person is just taking their time and they're very methodical and they're getting all their stuff and putting it on their salad, and they're very careful with the tongs and all that stuff. And you're like, oh, for crying out loud, speed up already. Well, that's a head-of-line block. Well, what would be a better way to improve that? Maybe if we had 2 salad bars so that other people could go through a little bit quicker in the other salad bars while we wait on this person to finish up their salad. And so we're multiplexing and we're using head-of-line blocking. We're getting rid of that. Also, we're improving congestion control. If you think about these blocks of data going out over the wire, they're going to be with a lot of other blocks that are out on the wire, and there might be some congestion on the wire, and what's happening is we're just improving that congestion. This is very interesting as well, number 4. Now, if I'm in a car, I've got my cell phone, I'm on the web, I'm going to go from tower to tower, and that probably implies that I'm going to get a new IP address every time I change towers, or at least during certain times as I change towers. Quick has the ability to keep the connection even while I change an IP address. I just think that's completely amazing. It uses TLS 1.3, that is a encryption protocol, and this is the latest version of it. And what it does is it securely encrypts your UDP connection. We're not using TCP, we're using UDP. We're throwing these blocks of data out the door and saying, here, go reassemble yourselves when you get to the other side. And oh, by the way, be secure, just be secure. Well, that's really cool. And even more, it improves on that because it says, even if somebody did manage to get into my secure connection, they were somehow able to undo that and get into it, they could not see the history backlog from before. The only thing they would see would be the current connection. So it's pretty cool, and I think it's going to be very, very difficult to get into one of these encrypted messages. And then it uses streamlined error correction. What does that mean? Okay, well, we talked about numbering the blocks. Block 1 of 5, block 2 of 5, block 3 of 5, block 5 of 5. And we do what's called an ACK. I ACK block 1, ACK block 2, ACK block 3, ACK block 5. Oh, I didn't get block 4. What happened to that? I'm going to negatively acknowledge that. It's called a NAC. And I'm saying, nope, I didn't get block 4. I need that to assemble the message. So we ask for a retransmit on block 4, and I send you block 4, and now you're able to put the message together. And so what's happening here is they have streamlined the ability to do some error correction like that so that that doesn't happen. So that is HTTP in a nutshell. Very, very interesting history, I think. All right, now here we are in Kali Linux. Now, I remind you that I went ahead and installed Mutillidae II directly in Kali Linux using a Docker image. It's actually 5 Docker images, and I made a movie on how to do that. And the reason for that is because trying to use old Mutillidae on Metasploitable 2 isn't working very well, and so I wanted to run it locally so I could go through these labs because they're a good training source for us to figure out about how to do website vulnerability testing and things like that. So I'm going to grab the terminal here and open it up. I'm going to, normally I would do a sudo apt update like that, but I've already done that in this case, so I've already got that. And you recall that we installed Mutillidae in a folder called Mutillidae Docker. Actually, just by grabbing the Docker image from Mutillidae II, it installed that, made that folder for us. So we're going to change to that folder. I'm going to clear the screen, and now I'm going to do an ls, and you recall that we've got this yet another markup language file here that is describing how to start these respective Docker containers. So I'll do sudo docker compose up, and that will actually start the containers for me. And this window has to say open the entire time that we're working here. Now this is actually a really quick lab. There's not a lot to it. So I felt like it was good to be able to take the time and show you how HTTP has evolved over the years, because I think that's a pretty interesting history. And so this is running, and we can just go ahead and minimize this and leave it alone. I can pull up Firefox here, and I can take a look at Firefox and look and make sure it's running, and I can look at the lab as well. So let me go out here to 127.0.0.1, which is where this thing is running at. There's my lab. If I go to labs, how the web works, lab 4 is where we're at now, and I click that, it's going to take me here and show me, oh, you need to tell me what the version of HTTP is, but it wants us to use Burp Suite to do that. Now I really love this. It's asking for a very simple thing which you could use in a lot of different methods, but what it wants us to do is try using Burp Suite, which is an amazing, fantastic tool that was written by Portswigger. And what we want to do is we want to really get more skilled at using Burp Suite because it allows us to spot web vulnerabilities, SQL injections, and things like that. Okay, so I don't really need this. I just wanted to show you the question here. Use the Burp Suite proxy to determine the version of HTTP. So it wants to know which of these versions we're using. I'm going to close this because I am not going to use Firefox. Now, if you're watching older videos about how to use Mutillidae or other, you can watch a movie on SQL injections using Burp Suite, things like that. What they'll do is they'll use Firefox, and they will load up a Firefox proxy called Foxy Proxy, a Firefox extension called Foxy Proxy. I don't really care to use that. I'm happy with using Burp Suite's internal browser, which is just a fork of Chromium. So I'm going to go ahead and open up Burp Suite here. This teal screen, this blue screen is perfect. That's telling you that everything's good. I have showed you how to do an update on Burp Suite in previous movies, so if you need help with that, go back and watch those movies. I do not have Burp Suite Professional. I have Burp Suite Community Edition, and so the only thing we can do is open the project up temporarily in memory. I'm going to use the Burp Suite defaults, and here's Burp Suite. So it doesn't take it long to run, and what Burp Suite is useful for is finding out stuff about websites. So you could go in and examine PHP or JavaScript, or you could look at databases, you can find vulnerabilities in websites, and all this kind of stuff. It's a really cool tool. I like it a lot. I will have you recall that on the top menu here, this is your top menu. Then there's a secondary menu, and we're going to wind up using proxy today. And now there's actually a third menu, a tertiary menu down below here. And we want to take a look at these buttons. So right now we do not have the browser open, nor do we have intercept turned on. First thing I'm going to do is open the browser, and it'll bring up this Chromium edition, which is fine. I think it's actually better than trying to use Firefox and Foxy Proxy. And if I'm being honest with you, whoever developed Foxy Proxy has updated it of late, And it's a little more complicated to be able to use these days. I'm not a fan of it anymore. I used to really like it, but I'm not a big fan of it since it's gone through an update. Now I'm going to go out here to labs just like before, how the web works, lab number 4. We get the same question. It wants us to use Burp Suite to find our proxy HTTP history. That's what we're trying to do. So I love this lab because it's forcing us to use Burp Suite. Now here's what I'm going to do. This is very simple. I'm just going to turn intercept on. I'm going to go back here to my lab, go home. All I'm doing is generating some HTTP traffic. Click forward. You remember that you have to do that because now what's happening is Burp Suite is acting as a proxy. It's intercepting everything that you're doing, everything that you're getting from the web and sending to the server. It's doing both of those things, and so you have to tell it that I want to forward this on so that I can continue working. Let me go out here now to labs, how the web works, lab 4, and again I have to forward this on. Now I want to show you the main thing that we're paying attention to here right now, and we're going to get to the point where we want to be able to read all of this information as we go down here and figure out what it is we're looking at. That's the secret. That's really the secret sauce to Burp Suite. What it does is it helps us to be able to see what's happening. We can find areas where maybe there's a problem or we want to introduce a problem. But what we're doing right now is we're just going through the basics and we're learning the basics of how to read these web pages, these HTTP headers. So we know that we have a GET here. I'm on line 1. That's the only thing I'm going to look at, and I've got a GET right here. The next part is the path. So what it's trying to do is trying to load up index.php. And you recall that PHP is a server-side web programming language. Today, JavaScript does a lot of the work. PHP still does a lot of the work. You probably should learn PHP if you're interested in that. And then PHP uses a question mark. So this is a query. This is saying, oh, would you please show me this page, labs, so it's going to take me into the lab folder, / lab4.php. So this is really good information because it's already giving us a path as to what we're going to go and what we're going to do. And the only thing that I would counsel you about is this question mark. Whenever you see this, you can be pretty sure you're looking at a PHP server session, and so it's expecting some detail after that question mark. And finally, here's the answer to our question. It's HTTP 1.1. So that's it. That's all we've got. So I can turn intercept off now. I can go back here and answer the question that it's HTTP 1.1 and submit. Bada bing, bada boom. That was pretty easy. And I'll talk to you in the next movie. Have a great day.